Wow, lathe talks. It occurs to me that I've had my Warco WM 180 lathe now for a little over 3 years, and I thought it might be helpful to other people who are maybe contemplating buying a mini lathe like the Warco, or have already bought one, just starting out with it. I thought I'd sort of share my thoughts on my experiences with the lathe, and also the things that I've basically learned over that period of time with it, and particularly what is important. And hopefully, as I said, this will be helpful to anyone contemplating going down the same road that I did. Now, as I've said before in my videos on the Warco lathe, I am not a machinist. I do not claim to be one. I am simply a hobbyist who uses the lathe as a tool in pursuit of his hobby, which in my case is repairing and restoring model steam engines. That being said, I have used the lathe for lots of other things. I've made all sorts of parts for, made some bits and pieces for a friend's weather station. I even made a brass ferrule for a beer pump in a pub once. So it's been used for a lot of different things, and it has performed superbly. And I'm overall extremely pleased with it. I paid, I think it was about £840 3 years ago. I think they're a bit dearer now. I think they're nearer the £1,000 mark. But yeah, it's an excellent bit of kit. I'm very, very happy with it. So, what are we talking about then? Well, first up, with this lathe, you have to accept the fact that it is a very, very small bit of kit. There's my arm. Right, and my arm from the tips of my fingers to my elbow is almost as long as the bed of this lathe. So this is a very, very small lathe, which is fine. And obviously I don't have room for anything larger. And for the kind of work I do, it's perfect. Its size is fine. But it does come with a few problems. Basically, there is very little mass to this lathe. It's very lightweight. So one of the things I discovered very early on when I was using this is that rigidity of holding the work and also the tooling is of paramount importance on these little lathes. You really do have to think about how you're holding the work. So let's come in a bit closer. About a year after I got the lathe, I was converted over to using collets by my good friend Rob on the Zanudo YouTube channel. Now, he is a great exponent of collets, and once you start using these things, particularly if you do a lot of round bar work, particularly small size round bar work, these things are light years better than a conventional chuck, like a 4-jaw or 3-jaw chuck. They really hold the work and support it superbly. They do not damage the work. You can hold threads in these without causing any damage. They are absolutely brilliant. And I use these pretty much all the time. As you can see, at the moment I've got my ER40 collet plate on it, which, okay, it's probably a bit on the large size for this little lathe, but the reason I like the ER40 collets is because it allows you to go up to about 30mm. In the collet, the maximum size it will hold, and that's really useful even for small model steam engines like I do. So collets, absolutely brilliant, superb at holding the work rigidly, which is what you want. The other thing is, use the tailstock. This is not an ornament, it's on the lathe to be used, and it is extremely useful when it comes to holding the work, supporting the work. Even if you've only got a small bit of work sticking out from the chuck, say even 2 inches, wherever possible, always center drill the end, bring the tailstock in with a center on it, and support it using the center. It will help you no end in cutting down chatter on the lathe and also improving the finish of the work if you do that. Also, we'll bring you in a bit closer now. This was something else that my good friend Rob put me onto. This is I call it a necked center because it's very narrow here. The problem with traditional live centers, this is a live center, is that it's quite often difficult to get the tooling in at this end of the work where it's been supported by the center. But with one of these, No problems with that at all. This is my go-to center now. Since Rob did a review of these, I got one straight away and I have not looked back. I use this all the time, and you can go right down to small bar stock and support with this. It's just brilliant. So use the tailstock. It's there to be used for many reasons, obviously drilling and stuff like that, but use it to support the work. It will definitely improve the quality of what you turn out, and again, reduce chattering. The other side of the rigidity equation, for want of a better word, is this lump here. Now, the carriage with the cross slide, the compound slide and the tool post, this is designed to be moved. Obviously, it can't function if it can't move. And because of that, it is not particularly rigid. This structure is not that rigid. But there is a simple mod particularly that you can do to improve the rigidity of this structure. I'll show you exactly what that is. It's very easy to do. The Warco WM 180, and I'm sure other similar mini lathes, do not come with locks to lock the compound or the cross slide. Now, yeah, okay, you can wind the gib screws up, tighten them down, and that will lock both the slides. But I'm sure you don't really want to be doing that, because if you're like me, you know, I spent some time setting the gibs up to get my slides to move the way I just wanted them to move, and I don't want to disturb that every time I want to lock the slide up. So here's a really, really simple way of fixing that. All you need to do is take the compound slide off and the cross slide off. Certainly on the Warco that's extremely easy to do, and I'm sure it is on other mini lathes as well. And what I did was, on the same line as the gibs adjusting screws, I simply drilled and tapped another hole. I used a screw the same size as the gib adjusting screws and put an extra screw in. And I've done exactly the same down here on the cross slide, which you can't see from this angle, but it's exactly, the cross slide is exactly the same. Now, if I want to lock the cross slide or the compound slide, all I do is just wind that screw in and the compound slide is locked. And the same for the cross slide. And this helps immensely in making this whole thing more rigid. And to be honest with you, you know, a lot of the time you won't be moving the compound slide. Most of what you'll do will be done on the cross slide and the carriage wheel. You won't be moving the compound slide, so just keep it locked. And it will keep this whole thing much more rigid, basically. Now, the final component, when it comes down to rigidity on the whole of this structure, is of course the tool post. And you'll have noticed in my videos that I use these conventional 4-way tool posts. This is exactly the same tool post that came with the lathe, and I'm still using it. Now, a lot of people like quick change tool posts, and I've got absolutely nothing against them. They're fine. A lot of people get on really well with them. You know, I prefer these. I like these. The simplicity of the design of the 4-way tool post is great. And one of the things that I love about it is the fact that unless you've got something like this parting off tool, and we'll come to that in a minute, conventional tools, you've got no overhang. It does not stick out the side of the tool post. It's right in close to the clamp pivot of the post. And that makes it quite a rigid structure. And basically what I did, I mean, okay, you can say it's a bit of an extravagant sort of thing to do, but I've got 3 of these identical, and there's 6 tools that I mainly use. This is my main cutting tool, carbide tip, index 1. That's my parting off tool, and the other 2, I've got a boring bar and a shaping tool in one, and a chamfer tool and a facing off tool in the other. And those are the 6 tools that I mainly use, and I just simply swap the tool posts over as and when I want them. It's very quick to do that. So the other thing is I've tried many different types of cutting tool, not just the difference between, you know, HSS and carbide. What I mean is I've tried different sizes of tools in the tool post, and I thoroughly recommend that you go for the maximum size tool that will fit in your tool post, and you can still level it and get it on center with the chuck. The bigger the tool, the more rigid it is. So again, this all helps with preventing chatter and getting a much better finish. These are 12mm square, these ones that I've got in here. That's basically oversized for this tool post. I actually had to skim the bottom of this on my milling machine to get it so that I could center the point on the chuck. But it was well worth it. I've had much better results with these big tools than I ever had with the little smaller ones, like the 8mm ones, even the 10mm ones. This is the way to go. Biggest tool that you can get fit in your tool post, basically. That brings us on to the parting off tool. Of all of the tools that you're going to use on your lathe, the parting off tool is the one that's going to give you the biggest headaches and the biggest problems on a small lathe, mini lathe like this. It's a shear tool, and it really is difficult to find one which really well works properly. Certainly I found that. I went through all sorts of different parting off tools, and again, this one is oversized, full tool post, but this is the only one I've actually come across which works. You can actually take decent rate of cut with this, which with all the smaller ones I couldn't. But again, it's massive, and say go for the biggest thing you can fit in, but still get the tip level on center. That's what I'm saying about the tool post. Certainly in my experience, that is what I found. And you know, as I said, I literally did a lot of experimentation on this. I tried all sorts of different types, and this is what I ended up with. So yeah, rigidity, work holding rigidity, tool holding rigidity, paramount importance. Fit lock screws to your compound and your cross slide. You won't regret it. It definitely helps. The other thing that I have found to be extremely important, and this is something which doesn't get talked about a lot, I've noticed on channels that deal with working with lathes, and I think it should be talked more about really, and that's speeds and feeds, particularly on the mini lathe speeds. Now, if you're gonna get a lathe, it's well worth investing in some literature with information, basic information in there. You know, the Zeus books are brilliant, the little black machinist books, and of course the machinist handbook is, you know, probably the Bible. And these have all sorts of charts of information in, and they will all have in them the correct speeds for turning and machining different types of metal. Okay, and that is normally in surface feet per minute. And there is a very, very simple equation that you can use, which you can then generate from that equation what RPM you should be running your lathe at for any given size of metal that you've got in it. And I'll show you that equation because I've actually got it pinned up on the wall in my workshop. So there you go. There you can see that is the simple equation that you use to determine what speed you should be running your lathe at, depending upon what metal you've got and what diameter of the metal. Now, as you can see, that says milling cutter RPM up there. The equation is 4 times the cutting speed in surface feet per minute divided by the tool diameter. If you simply replace tool diameter with diameter of the workpiece on the lathe, that will give you the RPM that you need to be running your lathe at for machining any given bit of work. Now, various different books will give you slightly different figures for the surface feet per minute. Now, I've got up on my chart there, I've got mild steel, tool steel, cast iron, aluminium, brass, and right down the bottom, stainless steel. I mainly work on brass and aluminium because I'm working with model steam engines. But I do, obviously, sometimes I do some mild steel work, very rarely tool steel, and occasionally cast iron. Generally, when I'm doing flywheels, if I'm cleaning up an old flywheel, quite often on old model steam engines, it's cast iron. And that is where we run into a little bit of a problem with these small mini lathes, and I'll come on to that in a minute. This equation, this is a godsend. You know, I'm not saying that you should, you know, this is not law or anything like that, but it gets you in the ballpark for the right speed that you should be running your lathe at. And it's so simple, you can memorize it. You know, because I use, you know, brass and aluminium all the time. If I've got a bit of brass, I know that it's 300 surface feet per minute times 4, that's 1200, divided by whatever the size of the work is. So if it's 1 inch bit I'm turning, then I can run it at 1200 RPM. If it's half an inch, then I run it at 2400 RPM. Or on those kinds of things, you know, it's absolutely fine. Let's come back onto the lathe. And the speed brings me on to the last thing I want to talk about with these mini lathes. Now, I'm sure it's very similar for other makes, but the Warco, the WM180, it's quite an old design now, and it uses a brushed DC motor. Nothing wrong with DC motors. They're fine, they're very powerful for their size, and from the manufacturer's point of view, they're cheap, as are the speed controllers for them. However, and this is a big thing that you really need to be aware of if you're running a mini lathe. They get hot when they're running at low speed. They also don't produce a lot of torque at low RPM. And you're thinking, well, yeah, okay, most of the time I'm going to be running this lathe at reasonably high RPMs because I'm going to be dealing with small workpieces. And that's true. But even on a lathe this small, it's perfect. It should be perfectly acceptable that you might possibly be turning something of 4 inches in diameter, which is not huge, and this lathe will certainly do that, no problem at all. But this is where you might run into problems. For example, when I made the Retro Steam Tech electromagnet engine, I made the flywheel for it. It was about 4 inches in diameter. Well, that's fine, but if we go back to our little equation, you know, aluminium's surface feet per minute is 250. You multiply that by 4 and you've got 1,000. Divide that by 4 and you're back down to 250. So a 4-inch slug of aluminium being turned in this lathe needs to be rotating at around 250 RPM, which is very slow for the electric motor. And it will do it. And I did it. I produced a very nice flywheel for my electromagnet engine. However, in the process, I also managed to burn out the armature windings on the first motor that I had in this lathe. And I was aware of the fact that they can get very hot, these DC motors, when you're running them at low RPM and you're putting a load on them. And I thought I'd left it, you know, I took breaks between the machining and all this kind of stuff. But no, I managed to bugger it up, and I had to get a new one. Warco are absolutely brilliant. I have to say, their first class service. Every time I've been in touch with them to buy stuff, and particularly with the replacement motor, they were great. I had it within 2 days. It was that good. So why do they overheat then? Well, let's take a look at it, shall we? Well, here is my original DC brushed motor from out of the Warco. It's looking a bit dusty because it's been sat under one of my workbenches. But yeah, part of the reason is that the only cooling on this motor is, I don't know how else it's going to show up. Inside that end, there is a fan. The fan is mounted on the armature. Now, as you can probably imagine, if that armature is spinning at 1200 RPM, that fan is sucking in a shitload of air, and it's going to be cooling the motor really efficiently. You slow that down to 250 RPM, or, you know, if you're going to be turning cast iron, you'd be going even slower, because cast iron is very, very low cutting speed. So that fan is not really going to be doing an awful lot at low RPM. The other thing is, these motors get hotter at low RPM. They're designed to run fast. So I'm not trying to put anyone off getting one of these lathes, because they're absolutely brilliant and many people have got them, have had no problems with them whatsoever. It's just something to be aware of, that they're not particularly suited to low speed work. Now, that being said, as you know, if you've watched any of my previous videos on the Warco lathe, when I fitted the new motor, I strapped a temperature probe to the case, and I've got this little display up here on the top of the lathe, which tells me the temperature the case is at. Now, as Rob quite correctly pointed out, the armatures are what get hot, and the case will follow the temperature rise of the armature, but whatever the case temperature is, the armature is going to be hotter. So I feel much happier about running the lathe at low speed because I've got this temperature monitoring on it. And basically, if the case gets up to around 30 degrees C, I turn the lathe off, and I've also got a cooling fan, which I've plumbed into the back. I'll take you around to the back and have a look at that. That will blow air into the compartment where the DC motor is, and it cools it down pretty damn quickly. So we're around at the back sheet of the lathe, and underneath this little wooden box here, I'll take that off, I have a little computer fan. This is a computer case fan from a PC, and it's obviously it's not a huge fan or anything, but I've cut a hole in the back sheet behind this, and this is more or less in line with the brushed end of the DC motor. But more importantly, it simply blows air into the motor compartment, and it can come out under the front. And that is enough to, just that small fan is enough to bring the temperature of the end of the motor down very, very rapidly. And then you can, get on and use the lathe again. And I will quite often leave it running. The little wooden cover is simply to keep the crap out of it when it's not being used. I was in two minds. When I first put the temperature probe on the motor, I didn't fit a fan, but I thought, well, nothing ventured, nothing gained. We'll try it, see whether, and it helps immensely at keeping the motor cool. So, very useful mod to do. Well, that's about it really. If I think of anything else, I'll do a follow-up video, but I really wanted to pass on what I've learned and what I feel is important when using one of these small mini lathes. And as I said, I've had this for 3 years now, and it's had quite a lot of use, and it really has been outstanding. It really has. Also, obviously, go out there and make use of YouTube. There are some amazing people on YouTube who are proper professional machinists and have got excellent YouTube channels which will teach you all sorts of stuff, particularly with mini lathes. I mean, obviously for me, Aid from Aid's Workshop, who I've mentioned before many times on my channel, he's got one of these, and what he does with it is just incredible. Go and watch some of his videos. I mean, it's just absolutely amazing. But there's also people like my friend Rob who have got years of experience using lathes, and Rob's got a whole selection of lathes from even smaller ones than this. He's just a mountain of useful advice when it comes to things like this. But there's loads of people out there. There are literally loads and loads of channels. Many of these people have got, as I say, got years of experience in using lathes, and they share it quite freely on YouTube, and you can learn so much from watching them. Well, that's about it. So yeah, overall, I am incredibly happy with this machine. It does everything I want it to do. Obviously, you just have to accept that the small lathes, mini lathes like this, they do have their limitations. And as long as you work within those limitations and don't try to push it too much, like I did with the flywheel, they're absolutely fine. So that's it. I hope it was of some use and help to anyone going down this road with one of these little mini lathes. As always, thank you very much for watching. Cheers.